Hi folks, now this is the second part of talking about the terrestrial planets, so we're going to be talking about Venus. Now as you full well know, Venus is very similar to Earth, about the same size, same density, it's only a little bit closer to the Earth, and as you can tell by this picture, it is very frequently uh, um, confused with UFOs, especially when it's close to the Moon. The reason for this, as exemplified in the astronomy picture of the day, is that Venus does not show a very, very large um, size relative, or a very, very large entity in relation to the Moon. It's rather small, and since it is almost point-like in its nature to us, the light from it can be moved around quite frequently. Very much like twinkling. So it can appear to move, and for that reason, people think of it as a flying saucer. And then finally, the last two statements I want to make about Venus is the atmosphere is the big deal on this planet, and it drives everything. I mean, it's big. The planet's big, about the size of the Earth, but the atmosphere is huge. And because of the atmosphere, it sort of has driven the impact, there's been a driven impact upon the surface of the planet. So the atmosphere has really driven it, as differentiated from our planet, where, it's the atmosphere is just sort of like scum on the top of a bit of water. Okay, so here we go with some details about the atmosphere. As you can see by this chart, we start with the atmosphere being starting off very high up, 100 kilometers, and then it comes down, and the pressure and the temperature increase almost linearly down to the bottom here, and the pressure is almost 100 times that of the Earth. The temperature in Kelvin is over 700 degrees. Now that's about 500 degrees of Celsius, and if we convert that to Fahrenheit, we're sort of talking in the neighborhood of 1400 degrees Fahrenheit. So it's a very, very warm place, and as you might know, lead would melt on this planet. So we have these upper layers of clouds, and this is what we see. We don't penetrate with visible light to the surface of Venus. Now, the greenhouse effect goes hand in hand with the increased atmosphere. And the increased atmosphere has a couple of effects. One is it increases the total temperature of the planet, but also it tends to moderate the daytime versus nighttime excursions. The actual greenhouse effect upon Venus is 500 degrees Celsius. And don't let anybody fool you, we do have a greenhouse effect on the Earth. If it wasn't for the clouds and the water vapor in the atmosphere, we would be at minus 16 degrees Celsius. It would be a freezing place. Now, the details associated with greenhouse effect, it's sort of a misnomer. A greenhouse has a couple of effects upon keeping a room warm. One is the visible light does go through the glass and then heats up the ground, and infrared radiation does not escape. But in a greenhouse, we also have a separation of wind and the pulling of heated air away from the surface, from the plants in the house, outside and distributing that heat. So that is the two effects of a greenhouse. About greenhouses. Now, the reason that we call this, this effect on planets is the following. We have incoming sunlight, and the sunlight then strikes carbon dioxide and other greenhouse gases, water vapor being the most significant one, as well as hitting the surface of the planet. And the surface of the planet absorbs this visible light and converts it into infrared radiation, or heat. Okay, it is this heat that if we didn't have an atmosphere, it would readily escape. But since we have an atmosphere, then it takes longer for this infrared radiation to escape back out to space. So the idea of going from an Earth-type environment to a Venus-type environment is that we have a thicker blanket of atmosphere. And for all the radiation that comes in, it takes longer for this radiation to escape and just continues to stay in here. Consider the following idea. If you are cold, you put on a jacket. All right. Now, suppose you are nice and comfortable now with this jacket. What would happen if you put on 20 blankets on top of it? Well, you would get really hot and sweaty. And after a while, you would get too hot. That radiation that was escaping from your body no longer is escaping, and it's just continuing to increase the temperature. And at some point, there'll be an equilibrium reached, but that equilibrium is probably not going to be comfortable for you. That's what we talk about when we're talking about greenhouse effects and runaway greenhouse effects, and why we are so concerned with global warming, or if you will, climate change. So if we, and here's a nice little picture about it. If we have more intense sunlight, then our planet can go into a runaway greenhouse effect. And that is thought to have occurred with Venus earlier on. The idea here is that at one time, Venus had water, had an ocean, just like Earth. But that ocean was heated up because Venus is closer to the sun. So there was more intense sunlight, and the atmosphere was warmer, and water vapor escaped. Water vapor escapes then as it gets closer to the upper reaches of the atmosphere. Then the infrared, not the infrared, but the ultraviolet rays from the sun can separate the oxygen from the hydrogen, and the hydrogen escapes. Basically, the idea is that we don't have any water left, and the carbon dioxide that forms the major constituent of the atmosphere of Venus has no way to get into the soil, which is, as you recall from last week, the major portion of where carbon dioxide is on Earth. All right, now we're going to talk about the surface a bit, and we're going to talk about how there is a deep connection between them. But first, let's talk about, the deep connection between the atmosphere and the surface. But first, let's talk about some of the standard things we've found on planets, basically craters. Now, there are some impact craters, and here's a picture of 3 of them. The surface of Venus has highlands and lowlands. It's basically material that's very similar to Earth, and you could imagine certain regions here, these low areas colored in blue, this is a false color photograph, are the low-lying regions, and you can imagine that these could be ocean basins. Of course, there's no water anymore on Venus, and these higher regions would be what we would label continents if we had a similar situation on the Earth. Now, there are other things that are kind of reminiscent of Earth-like structures, namely mountains that are very tall, folded mountain ranges, suggestion of movement of the crust. And there are volcanoes, and there are regions where we could have calderas being formed. So there are similarities here, but we also have very distinct features on Venus. In particular, this one. This is a feature called whatever that word is. And these bulges, and there are a few of these guys, are very large. And they appear to be caused by the upwelling, as it says, of magma pushing up under the crust. And so we have regions on Venus where material is flowing out from the interior of the planet, and we also have regions where it's flowing in to the planet. So the convective currents that we know are occurring on the Earth, sort of driving around the crusts, right, and of the Earth, and the earthquakes and this fault slipping and things like that occur on Venus. But we don't have a crust because it is so really hot there that the crust is really more just like a more solid mantle. Okay, so it just sort of gets pushed up, and no real uh, no real plates, tectonic plates, can occur. All right. Basically, the last bit I want to say about here is, this information has come from robotic, entities or robots that we've sent up, and they don't last very long. The reason why is it's 90 atmospheres of pressure on the surface, and it is so hot that everything melts. And besides that, we've seen that in the atmosphere's got essentially not only this awful witch's brew. It was more like Hades, is what the chart said before. The sulfuric and nitric acids don't allow our robots to last very long. All right, so one of the interesting things I found in this chapter was that the history of Venus and the history of Earth are very similar very, very early on. The difference is the position of Venus relative to the Earth and the Sun. And take a look at what this guy is saying. If the Earth moved closer to the Sun, then we would have a runaway greenhouse effect, and the planet would turn into Venus. Basically, if we converted, as it says, if we converted all the Earth's carbon dioxide, then we would have an atmosphere that would be just as dense as the one that is on Venus. The only reason that we don't have this carbon dioxide in the atmosphere is because water absorbs carbon dioxide, as you well know from drinking Coca-Cola and other soft drinks. But it being in our atmosphere would create a really warm atmosphere. Water would evaporate. Water would get close to the upper atmosphere. Hydrogen and oxygen would dissociate. The oxygen would combine with other elements, creating nitric and sulfuric acids. The hydrogen would go away, and we would have no more water. Pretty bad situation. So, another point saying is we ought to curb our creation of carbon dioxide in the atmosphere. All right, so let's continue on. Because it's so hot there on Venus, we don't have any sign of plate tectonics. The crust is basically not a solid. It's more of a glassy texture. And let me remind you that glass is a very, very slow-moving liquid. So that's sort of the idea I have for the surface of Venus. It is solid, but it moves slowly. Okay, sort of like if you walked on a piece of glass. There are other structures on Venus that are very similar to Earth. And that gets us to our next planet, which is Mars. So we'll pause here, and we'll start up in a little bit.